Welcome to reInvent 2017 recap. We only have an hour to go with so much content to share. So as Andy Jassy would say, let's giddy up. So let's take a quick look at the agenda for today. What we're going to first cover is key definitions used throughout this DEX. We're going to also talk about a couple of ways we summarized all the content for you. And then we're going to spend the most time covering all the launches in more details. So we have a number of presenters helping out us today. Myself, Evgeny Vaganov. I'm an expert in compute and networking.
Hello there, my name is Mitch Beaumont. I'm a solutions architect who specializes in containers and DevOps.
Hi, my name is Jared Speaker. I am a solutions architect out of Sydney that works with media and entertainment customers.
Hello everyone, my name is Ed Lehman. I'm a specialist in everything serverless, IoT, and related to development.
So the reason we got all together today is to discuss all the announcements we've done at reInvent. In fact, we had so many announcements that we had to pull some of them forward, and we actually announced them during the months of November. So what we're going to do for you today, we're going to cover anything that became generally available. We're going to make an accent on all the things which are available in Sydney for you today. We're also going to discuss all the services that launched in a preview mode, and we're also going to recap some of the significant announcements which were pulled forward. So I mentioned before that we summarized content in a couple of ways for you. So we summarized them in a matrix, which contains all the announcements, if it's generally available or it's in a preview, and also the regions where the service is available for you. Now, this content will be recorded and available to you in a few days, as well as the slide deck will be shared on SlideShare website. The links will be sent to you, so we're not going to spend much time here to going through this matrix. We also summarized all the content for you by technology domain. So essentially, we'll be able to see something like this. You'll be able to see the name of the announcement, short description, and also whether it's generally available, pre-announced, or available in Sydney. So again, we're not going to spend much time here. You'll be able to see all this summary decks on SlideShare, and we'll get straight to the detailed slides. So to start off, we're going to cover artificial intelligence and machine learning. So over to Jared.
Hi everyone, I'll start by introducing Amazon SageMaker, which provides an easy way to build, train, and deploy machine learning models for everyday developers. We have three main components in SageMaker: build, train, and deploy. In the build phase, SageMaker can give you the option of using pre-built Jupyter notebooks to explore your data, or you can provide your own. When picking algorithms, again, you can use algorithms supplied by SageMaker, or you can bring your own. For pre-supplied algorithms, we've taken the 10 most popular and heavily optimized them so that than what you would see elsewhere. We've also carried out extensive optimization for networks of the framework used to train your models. Training is also much easier. Specify where your data is, select the instance type, and SageMaker will spin up an isolated auto-scaling cluster and will start training. And when training is done, SageMaker tears down the cluster for you. If you get promising results and need to tune a model, one of the ways you can do tuning generally is through hyperparameters, typically something that's taken a lot of time and effort to do. SageMaker optimizes this process. Check a box at the beginning of tuning and it will spin up multiple copies of your model in parallel. We will then have machine learning inception here, as machine learning informs the machine learning model to improve the way that your models are built out. When you want to go and deploy, all you need to do is pick an instance type and some simple thresholds. One click later, SageMaker will deploy your model across multiple availability zones, complete with auto-scaling and HTTPS endpoints. Finally, these three components can be used in isolation. If you want to build and train your models in SageMaker but deploy them elsewhere, you're completely free to do so. One of the devices that you can roll out SageMaker models to is AWS Deep Lens, the world's first deep learning-enabled video camera for developers. This is a 300-gram device that packs over 100 gigaflops of compute power. The device is aimed for developers who want to use neural networks to learn and make predictions through vision projects, tutorials, and real-world hands-on exploration. The device comes pre-installed with an optimized inference engine using Apache MXNet and will soon provide TensorFlow and Caffe engines. And as always, you're free to bring your own. The device also seamlessly integrates with a multitude of AWS services. A couple of examples that I'll briefly touch on include AWS Lambda, as the deep learning models in Deep Lens can run as a part of an AWS Lambda function. Content from the camera can also be streamed into the Amazon Kinesis Streams video service, or more advanced video analysis can be achieved by using Amazon Recognition Video, both of which we'll cover on later in this webinar. At this stage, the devices are only available for pre-order within the United States. Over the last year, a lot of customers have been using the recognition service to detect faces and objects in images, but many customers have asked if we could do the same thing for video. Now we have Amazon Recognition Video. This service can operate in a couple of ways. You can use recognition to process the content to automatically generate video metadata. As is the case with processing images, video recognition returns things like labels of activities, people and faces, celebrity detection, object identification, and so forth. And all of this metadata has associated timestamp information. Another scenario where video recognition could be used in the processing of live streaming content. Features such as live person tracking could be used for public safety use cases, where you could identify a known person of interest using facial recognition and track their movements or activities through scenes. But this is just the first of the AI services that we've launched that allows you to automatically extract metadata from content. If you supply text content to Amazon Comprehend, it will identify the language of the text, extract key phrases, places, people, brands, or events. It can also understand how positive or negative the text is and can be used to organize collections of text files by topic. Comprehend is always learning new data and continually gaining a deeper understanding of the elements that it identifies, including the data that we feed it from Amazon.com. Loading data into Comprehend is simple. You can directly reference objects stored in S3 buckets, or you can use AWS Glue to load text from various AWS database or data warehouse sources. One of the use cases for this service includes sentiment analysis of call center transcripts or social media feeds. It'll actually be interesting to pass the comments that we get through on this webinar to see how we're doing with this service. But what happens if you have audio with no accompanying transcript? We can use the Amazon Transcribe service, which is designed to provide transcripts of audio content. Using deep learning, Transcribe provides punctuation and appropriate text formatting, resulting in output that is much more reader-friendly. Additionally, the service has been built in order to provide transcripts for low-quality audio to enable use cases such as the transcribing of customer phone calls. And every word in the transcript is paired up with a corresponding timecode. An example of this in use is by a Sydney-based customer called Essentia. They use Amazon Transcribe to analyze and monitor media coverage for brands that they provide services for, including 84 of the world's top 100 brands. Today, the service can transcribe content in English and Spanish, though support for more languages is coming soon. So we have an English audio clip transcribe. How do we make that content available for more of an international audience? Amazon Translate can take that text and translate it to Arabic, simplified Chinese, French, German, Spanish, and Portuguese, all from those languages back to English again, with support coming soon for additional languages. It's designed to be a scalable service, able to provide consistently fast and reliable translations regardless of the volume of text that is to be translated. A simple API is provided to easily integrate with the service with your own applications, allowing for the creation of real-time or batch translation capabilities within your applications. And as is the case with our other AI services, the translation engines are always learning from new and expanded data sets to produce more accurate and fluent translations. Both Amazon Translate and Transcribe are currently in preview. If you would like to get started with either service, you can sign up for the preview on each of the services page on the AWS console. And now I'll pass it back to Evgeny to talk about EC2 launches.
Thanks, Jared. I love how we make it available for developers to easily consume the AI and ML services through APIs with things like Transcribe, Comprehend, and Translate. But what if you need to train your own model with SageMaker? That's where you want to use your compute and EC2 instances. So let's have a look what we've done in this space. Back in November, we launched C5 Instances, pre-announced back at last reInvent. They used the latest Intel Skylake CPU, and they've also been built on top of the KVM-based Nitro hypervisor. So Nitro is the new hypervisor platform, which is new, lightweight, and it also gives us ability to expose the things like the actual resources in a more efficient way. So that allows us to reduce the prices while giving you more of the CPU power and also faster access to the storage. So we didn't stop here. We also announced M5 instances, which are generally available. So also using the latest Nitro hypervisor, Skylake CPU, and VME storage interface, and they're 14% more better than the previous generation M4 instances based on the price and performance equation. So one thing that you'll notice here is that networking performance for even the smallest instances now supports up to 10 gigabit. So this is a great improvement using the newest Elastic Network Adapter, or known as ENA. We also released X1E instances in Sydney. So essentially, they give you the highest amount of memory per vCPU, which is perfect for your memory-hungry applications, like in-memory databases. So the big call out here, we actually did some testing with SAP with those instances. And what we've done, we created a world's largest scale-out cluster with 50 terabyte of RAM, which is amazing. That's really a lot of RAM here, which set a world record for this type of a scale-out cluster. We launched H1 instances. These instances allow you to have a lot of storage, which is perfect for MapReduce, distributed file systems, and things like Apache Kafka. Another development is that we released EC2 Bare Metal instances. So this is completely new to the platform, something that we've been working on for a while for our VMware-based offering called VMware on AWS. So essentially what it is that you will be allowed to run a non-virtualized environments on top of EC2. You'll have full access to the underlying hardware feature set. It's based on the same Nitro hypervisor. Now, anything that uses Nitro will need a special AMI, which contains special drivers for NVMe storage and also the ENA adapter. This is available in preview, so we're very excited to see what you guys be able to do with this. We've done some changes to EC2 Spot. So Spot prices are now more gradual. We reduced the number of spikes, and essentially it's just more gradually changes over time. Spot instances are now available to be launched with a Run Instance API. So it just makes it easier. We don't need to call separate API for that. Spot instances can also now hibernate, which is pretty cool. Just like your desktop computer goes to sleep, you can have your Spot instances going into sleep. All your RAM gets stored on EBS, and when needed, it can wake up and basically restore to the same state as it was before. T2 instances now also available on Spot, which is very interesting. So other updates on EC2, we changed the EC2 SLA to 99.99. EC2 now supports volume shadow copy services. So essentially, you'll be able to do EBS consistent snapshots without using any third-party agents. T2 has a new unlimited option. So essentially, if you've been using T2 for your production workloads, occasionally you would run updates or maybe deploy a new set of patches for your application. And what will happen that you could consume your credits faster than you normally would, and that would create the bottleneck for your application. So with T2 Unlimited, you can essentially enable that feature, and for a bit of extra cost, will just allow you to continue to burst as needed, even if you run out of your CPU credits. Launch templates. We allow you to now create a launch template which contains all the parameters to launch your instance, so that can speed up things like when you launch your instance using Run Instance API. We also have now time synchronization service, which is very important for some of the use cases in the database world, which we'll cover in a few slides from now. The way that we made it available to you, it runs on the 179 special IP address, just like EC2 metadata. Essentially, the EC2 instance has a direct access to that. We also have AWS Systems Manager as now separate standalone service. So it makes it a region from EC2 Simple Systems Manager, or SSM. SSM has been developed over time with many different features like ability to manage your hybrid environments, ability to patch your systems, maintain security and compliance. It essentially became a one-stop shop, a central place to operate your hybrid environment. So this is now a standalone service and available in the console as a separate link. Okay, from that point, I'd like to hand over to Mitch to talk about all the awesomeness in the container space.
Thanks, Evgeny, and awesomeness is definitely a great word to use there. Just a point on your EC2 comments there, it's really great to see that we're continuing to innovate on behalf of our customers with EC2 10 years into EC2's operation. One of the common use cases that we saw with EC2 way back as far as 2013 was Docker containers. So back in 2014, we released Amazon ECS as a way to orchestrate Docker containers across a fleet of EC2 instances. And ever since then, we've been working hard to make sure that AWS became the best place for our customers to run containers. And off the back of that, two really exciting announcements were made at reInvent in the space of containers that I'm going to talk to over the next few minutes. First announcement that I want to share with you is AWS Fargate. Now, AWS Fargate is a new technology which is incorporated into the existing ECS platform that allows you to run containers on top of ECS without having to manage underlying infrastructure. What it allows you to do is operate entirely in the context of a task rather than the traditional instances which we used to have to deploy, configure, and join into the context of a cluster. Now, the cluster context does still exist, but instances that you now need to manage. When you provision tasks on ECS using Fargate, you simply need to declare the resources that you require for your task to operate and push that to the API. Fargate will take care of the rest in terms of scheduling and placement of those tasks on the underlying infrastructure that AWS now manages for you. So as you can see, the benefits of using Fargate: no instances to manage, which means that you've got no more patching of operating systems or patching of runtimes that you need to take care of. We've got a task-native API. That's to say that when you want to deploy your tasks, you now interact directly with a task-native API. You provide a task definition, you provide a container image, and that is essentially your cost of entry to use Fargate. All of the auto-scaling, monitoring, and heavy lifting of the infrastructure associated with that task infrastructure is taken care of by us for you. And you only pay for the resources that your tasks use. As I mentioned, we continue to use that notion of a cluster when using Fargate with ECS. It provides that isolation entity from the tasks that are running in different environments. So here you can see we've got a prod, a beta, and a dev, as well as a QA cluster. So in terms of ECS with EC2, your container instances are registered with a cluster, and those tasks are running on shared infrastructure. Similarly, with Fargate, tasks in a prod cluster may share the same underlying infrastructure with other tasks within the same cluster, but for example, the notification in the prod cluster will never share infrastructure with other tasks in the dev, QA, or beta clusters. We also introduced with Fargate the concept of a platform, which is essentially a container task infrastructure runtime environment. Given that Amazon now takes care of the managing of the container instances for you, some people ask, how do my containers now interact with other parts of my VPC? Well, we introduced task-level networking. So task-level networking allows us now to associate an ENI, or an elastic network interface, with tasks that are running within your ECS environment. All Fargate tasks now run within a customer VPC. So when you create those tasks, you'll define the AWS VPC network model. What this means is, because your tasks each now have their own network interface, you can associate things like security groups with them, as well as enabling capabilities like VPC flow logs. Each task now also supports the ability to assign a public IP address. So in addition to ECS, we got a message from a lot of customers about running other types of container orchestrators. One of those was Kubernetes. Generally, customers say to us, hey, running Kubernetes is not very trivial work, and we think we can spend our time better on developing software than spending time worrying about managing infrastructure in etcd clusters. So they also wanted to run native AWS integrations with things like Kubernetes. And then in addition to that, they wanted to continue to leverage their existing open source Kubernetes experience. So in response to that, we listened and we built Elastic Container Service for Kubernetes, or Amazon EKS. And we know it's very important to run a well-functioning cluster for our customers, so we didn't build EKS haphazardly. There are some core tenets that we built that we followed when we built EKS to guide the decision-making process in terms of infrastructure and architecture. EKS essentially provides a set of APIs that you can use to provision and manage the master cluster of your Kubernetes environment. Essentially, there are 4 APIs available for you now: describe, create, list, and delete. Obviously, we'll add more capabilities to that range of APIs as time goes by. As you can see here, we're managing the master node, or the master nodes for the EKS cluster. Essentially, by default, we'll deploy 3 master nodes for you across multiple availability zones. As a customer, you're then responsible for taking care of the worker nodes themselves. Those worker nodes can be deployed in a range of different ways. So you'll have the ability to deploy AMIs, that will include some pre-baked configurations. We're also going to open source the Packer scripts that we use to create those AMIs for you, so you can manipulate and change those as you need to incorporate those with your environment best practices and standards. We're going to continue to integrate with, we're going to continue to contribute to Kubernetes upstream. Any capabilities that we add to the EKS service will be embedded into Kubernetes upstream so that all customers running Kubernetes on AWS can benefit from those capabilities. And one really important point to call out here is that this will be native upstream Kubernetes. So if you're used to using native upstream Kubernetes, this will be no different. All of the functionality of Kubernetes will be exposed to you using the normal channels and mechanisms through the standard Kubernetes APIs using tools like kubectl. With that, I'm going to hand over to Ed to talk to serverless.
Thank you, Mitch. Very, very nice to hear all the exciting announcements in the container space. Now let's move on to serverless. So the first thing I want to talk about is the serverless application repository. We want to make it as easy as possible for AWS customers to discover and deploy serverless applications. We also want to strengthen the open source community around Lambda, SAM, serverless apps, with room for everyone to share, participate, and benefit. So as a quick refresher, SAM, which is the serverless application model, lets you define, model, describe, and set up related API gateway APIs, DynamoDB tables, and Lambda functions with a few lines of YAML code. So if you're already using SAM to build serverless apps, you're just about ready to start accepting contributions and adding your app to the application repository. You'll be able to use resource-based IAM policies to control access to your app. You can keep it private as well if you want to, granting cross-account access on an extremely selective basis, or make it available publicly. You'll be able to start using our apps from the serverless application repository just in the console, like we do with the blueprints. They'll be available there, and you'll be able to access them. Next announcement, it's AWS App Sync. For quite some time, we've had customers asking about GraphQL in AWS and when we would release a managed GraphQL service. Well, we don't have to wait anymore. The day has come. First of all, what is GraphQL? GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. It allows you to request only what you need and retrieve many resources from multiple sources with a single API call. In reality, AWS App Sync was announced as part of our mobile services, but I decided to add it as part of our serverless announcements because it is a full-fledged serverless service that connects seamlessly with Lambda and can be used in both mobile and web applications. AWS App Sync is a fully managed GraphQL service for real-time data queries, synchronization, communications, and offline programming features. You just need to create a GraphQL schema, connect data sources and resolvers such as Lambda, DynamoDB, Elasticsearch, and App Sync provides real-time access to data as well as support for offline access. With App Sync, developers can simplify the retrieval and manipulation of data across multiple data sources. It keeps data updated when devices are connected, but enables developers to build solutions that work offline by caching data locally and synchronizing local data when connections become available. App Sync also allows automatically handling of conflict resolution in the cloud backend as opposed to at the client, and manage fine-grained access control to secure access to your backend using resources such as Cognito user pools, IAM, or API keys. We also have some other updates in the serverless space. You can now shift incoming traffic between two Lambda function versions based on pre-assigned weights. This allows you to gradually shift traffic between two versions. Other than that, now AWS Code Deploy can leverage this new feature to automate the gradual rollout of new function versions. In the same way, API Gateway now allows to configure canary deployments, where a canary release receives a small percentage of API traffic, and the production release takes up the rest. After all tests are done, you can promote the canary release to production. We also release support for management for data events on CloudTrail. You could only log Lambda management events before, but now you can also record data events and get additional details on when and who invoked an API call that was made which Lambda function was executed. If you have workloads with higher memory or denser compute requirements, such as big data analysis, large file processing, and statistical computations, your Lambda function can now use 3 GB of memory, doubling the previous limit. Memory, as you know, is the only power dial for Lambda. The more memory you configure, more CPU is allocated to the function. With 3 GB, you can now also have access to 2 cores of compute for your function. You can now edit code for your functions in a robust IDE-like environment that's based on AWS Cloud9. We'll talk about more about Cloud9 shortly. And one of my favorite new features, you can now set a concurrency limit on individual AWS Lambda functions. This is very useful if you want to limit traffic rates to downstream resources called by Lambda, such as databases, or if you want to control the consumption of elastic network interfaces on a VPC and the amount of IP addresses for your functions. Another interesting use case is use this control as a kill switch for a specific function. You can set the concurrency limit to 0. It will kill all executions of your function. You can now provide access to private resources in private subnets with Amazon Virtual Private Cloud without exposing them to the public internet with API Gateway. It's important to understand the APIs to be public, but you act as a proxy to internal VPC resources. So all of these new features that are available are generally available in Sydney, but we also have a feature related to Cognito. Cognito has now adaptive detection features that understands unusual signing activities, such as signing attempts for new locations and devices. It assigns a risk score to the activity and lets you choose to either prompt users for additional verification or block the signing request. And now I'm going to pass on to Jared to talk about the media service launches.
Thank you very much, Ed. The first service that I'd like to talk about here is recently launched at the Midnight Madness event. It's called Amazon Sumerian. Sumerian is a web-based IDE that allows developers to quickly and easily work with virtual reality, augmented reality, and 3D applications quickly and easily without requiring any specialized programming experience. It takes 3D asset files that you can upload in either an FBX or an OBJ format. You can apply animations to those objects. You can script logic that controls the behavior of these objects using a visual editor or a JavaScript-based editor. You can also place 3D characters within the scene. You can see the Christine and Preston hosts that are initially available with the service, but you can customize a host's characteristics using their voice and language. Integration with Lex and Poly can enable engaging spoken interactions between hosts. For virtual reality environments, Sumerian currently supports AR applications are capable of running in modern browsers, and on the mobile front, ARKit can be used to build apps on the iOS platform, with AR Core support for Android devices coming soon. And now I'll talk about 5 related services. Back in September 2015, Amazon acquired a video firm called Elemental Technologies, a company that specialized in software-defined video solutions primarily aimed at broadcast organizations. For much of the last 2 years, AWS Elemental have been working on providing Elemental technology through the AWS console, the first of which I'll talk about is AWS Elemental MediaConvert. This allows you to transcode file-based assets, differentiating this service from the Amazon Elastic Transcode service. MediaConvert is designed to be broadcast grade. It supports ultra-high definition or 4K resolution content, graphics overlays, content protection, multi-language audio, closed captioning support, and professional broadcast input and output formats. To use the service, one simply creates a new transcode job, configures the job settings, and then start the processing. A comprehensive API is also available in order to allow MediaConvert to be an automated part of video processing pipelines. Pricing is based on the duration and quality of the output video and the features that you use. But to give you an example, a single pass SD or HD transcode using MediaConvert ends up costing around 20% less than the Elastic Transcode service in the Sydney region. The next service I'll talk about is AWS Elemental Media Live, which performs live transcoding of streaming content. Many of the broadcast-grade features covered in MediaConvert are also available in Media Live, including support for ad insertion or SCSI markers, audio normalization, and multiple audio tracks, including audio description tracks. Media Live also provides automated resource provisioning. If you need to transcode to additional formats, additional resources are dynamically provisioned to cater for those requirements. The service is also deployed in a highly available manner, with each channel running on redundant infrastructure distributed across physically separated availability zones. Like all AWS services, you only pay for what you use. You're only billed when channels are in a running state and based on the quality, bitrate, and frame rate of the inputs and outputs from the service, either on a per minute basis or on a per month basis over a 12-month term. It should be noted that this service is not yet available in the Sydney region. If you're interested in this service, I would strongly encourage you to reach out to your AWS account team to talk about your specific use cases. So now let's assume that we have media live transcoding an input stream into various mobile formats. How do you present this content to your users? AWS Elemental MediaPackage is a streaming origin service that provides just-in-time packaging features that customizes live video streams for delivery in the format compatible with the device making the request, while also applying digital rights management standards. We've developed an API for exchanging DRM key information that supports over 20 different DRM providers, including Apple's FairPlay and Microsoft's PlayReady DRM mechanisms. As was the case with the previous two services, a full gamut of broadcast-grade capabilities are also available, including multi-language subtitling and DVR capabilities. MediaPackage is also built for high reliability, automatically distributing resources across multiple AWS availability zones, and can automatically scale based on the incoming stream requests that you receive. The service continuously tracks metrics, and new instances are launched automatically to scale with increased workload as needed. As MediaPackage is charged based on the volume of content ingested by and delivered by the service, we recommend that you use the CDN with MediaPackage to maximize performance and minimize cost. Finally, we have AWS Elemental Media, we do have AWS Elemental Media Tailor, which is designed to provide server-side personalized advertising content to end users in a manner that reduces the effects of ad blocking software. It does this by generating and maintaining a unique manifest file for each viewer, which is used to deliver ad placements that are personalized to the individual. Advertising content is seamlessly inserted into the primary content stream and can be played from the same source location to reduce the risk of buffering caused by bitrate variability during playback. Client metrics can also be used to inform advertising decisions based on information the video distributor knows about the viewer, such as geographic location, browser history, or gender. This service works with most standard CDN or ad decision services. And finally, we have AWS Elemental Media Store, a low-cost alternative to video origination and storage. When you create or upload a video file in Media Store, it automatically holds a replicated version of it in cache for the first few minutes, providing predictable latency and great performance regardless of how many viewers are watching your content. After the first few minutes, content is stored in S3 and retrieved by the service when requested. And that about wraps up our coverage on media services. Over to Evgeny again, this time to speak about networking launches.
Thank you, Jared. So the core tenet of everything we do with networking on AWS is to make it flexible. So back in November, we introduced changes to our Direct Connect product. So essentially now you can connect to Sydney, Melbourne, Canberra, or Perth points of presence for Direct Connect, and you can have access to your VPCs running in any of AWS commercial regions anywhere globally. So essentially, once you connect, you can talk over Direct Connect to your VPCs running in Oregon, North Virginia, and other regions, and have access using that same link that you would use today for accessing resources in Sydney. On top of that, you'll also be able to talk to any public IP address advertised by AWS. So any service that's built and available publicly on top of AWS, you can use the same Direct Connect link to access that. We also introduced inter-region VPC peering. So previously you could peer VPCs within the same region, and now you can do it across regions. So initially in North Virginia, Ohio, Oregon, and Ireland, with other regions including Sydney coming soon. This allows you to send traffic across AWS private backbone, so it's not susceptible to different attack vectors for DDoS and other threat vectors. We also encrypt traffic as it traverses our private backbone. We also now have Private Link, which comes in the different flavors. Essentially, it allows you to have private VPC endpoint within your VPC. So all your applications are talking to the private IP addresses, and your VPC doesn't need to be on internet. With VPC endpoints and the private link, you can access services running in the shared services VPC. So if you have any kind of IP overlap, it's perfect for this use case. Also, if you want to talk to public AWS services like EC2 and AOB APIs, Simple Systems Manager, Kinesis, with more to come, you can use Private Link for that. And also our partners are using Private Link extensively. So you can talk to things like Heroku, Aqua, different providers like Snowflake over the Private Link without having to have your VPC exposed to the internet. And now I'm going to hand over back to Ed to talk about Internet of Things.
Thank you very much, Evgeny. Private Link is absolutely fantastic. I'm sure lots of. Let's get started with Internet of Things. First of all, we have lots of releases, but I'm going to start with the ones that are available in Sydney. AWS IoT Device Management is generally available in Sydney, and will help you through each phase of the device lifecycle to securely onboard, organize, monitor, and remotely manage IoT devices at scale, from manufacturing to initial setup, to software updates, to retirement. It's very easy to get started. You simply log into the AWS IoT console and register devices. Then you upload attributes, certificates, and access. Once devices are in service, the device management allows very near real-time, troubleshoot device functionality, remotely update software, remotely reboot, reset, patch, and restore devices to factory reset. So basically, it reduces the cost and effort to manage a large IoT fleet. You have some customers using it, Philips Healthcare, for instance. So part of the Philips solution involves managing connected devices that doctors and hospitals rely on. So they need to be very appropriately routed. Devices need to be updated to the latest firmware and monitor. So device management takes care of that. There's also another customer, Trimo, best known for its GPS technology. So it's using device management to help streamline the device onboarding. Moving on, we have now Amazon FreeRTOS. So a large number of devices, from light bulbs to conveyor belts to motion detectors, they're not big enough to house a CPU, and they use microcontrollers instead. So the most popular operating system for those devices is FreeRTOS, an open source operating system for microcontrollers that allows them to perform simple tasks. FreeRTOS wasn't designed specifically for IoT use cases. So we released an extension of the FreeRTOS embedded operating system with additional libraries for local networking and cloud connectivity. And this is what FreeRTOS is. So developers now can easily build devices with common IoT capabilities, including networking, over-the-air software updates, encryption, and certificate handling using FreeRTOS. You already have customers such as Allegiant that provides electronic locks, or Hive. They are a market leader in connected home products that manage energy usage in UK, Ireland, and North America. Now, AWS IoT One Click. So it's a service that makes it easy for simple devices to trigger AWS Lambda functions that execute a specific action. So simple devices such as single-purpose devices like buttons, badge readers, asset trackers, and motion sensors. The AWS IoT button is a perfect example for that. So simply select a device, associate the action, and then deploy your application. It's very easy to get started. So basically, you enable a device with an AWS Lambda function. You just need to download a mobile app, register, and select an AWS IoT one-click enabled device, and associate the Lambda function. We have a customer such as iRemedy, so it's a healthcare e-commerce marketplace. So customers simply click their iRemedy IoT button to order medical supplies or drug samples, or request a callback from the service center. Now moving on to IoT Device Defender. Security is top priority in AWS, and is no different for IoT services. So the Device Defender continually audits security policies associated with the device to make sure that they aren't deviating from security best practices, and alert customers when non-compliant devices are detected. It also monitors activities of fleets of devices, identifying abnormal behavior that might indicate a potential security issue. Moving on to Greengrass Machine Learning Inference. So inference is a new feature that we are implementing in Greengrass, and is in preview. So let's develop applications add machine learning to the devices. without requiring any special machine learning skills. So as you know, IoT generates lots of data, and you can use that data to train machine learning models, maybe using SageMaker. And that requires massive compute resources, so it's a very natural fit for the cloud to train those models. But inference takes lots of less compute power and is typically done in real time when new data is available. So with the inference model, you can get the best of both worlds. You retrieve data from your device, you then can train that in the cloud, train your machine learning models in the cloud, and then send that inference back to the device. And then the device can be offline, but still perform that sort of machine learning workload. Now, AWS IoT Analytics. It's a fully managed analytics service that cleans, processes, stores large amounts of device fleet data. So queries and analyze the data at scale. It also integrates with Amazon QuickSight for visualization of data and brings power of machine learning to integration with Jupyter notebooks. We have a couple of customers using analytics already, iDevices, for instance, or iRobot. And we also have now a couple of other updates. So Greengrass has 3 new features. So Greengrass core devices can now natively interact with the capabilities of the host, and now access local resources. Also improve the over-the-air updates of your Greengrass devices and support for OPC UA protocol. IoT Core now also adds OAuth capabilities. So in addition to having security certificates in your device, or as opposed to have security certificates in the device, you can authenticate and secure those devices using OAuth now. And just to give an idea of how our IoT ecosystem grows, so now we have solutions that can be deployed on devices itself, on things, and then connect those devices to the cloud, and then connect to enterprise applications and use partner solutions to improve that the deployment or customize that solution. Now moving back to Mitch with the database launches.
Thanks, Ed. And as they say, behind every good IoT project is a database. So I'm happy to talk to you about some exciting database launches that came out at reInvent this year. Let's start with Amazon Neptune. So Amazon Neptune is a fully managed graph database service, which is fast, reliable, and super scalable. It supports the popular graph models Apache Tinkerpop and W3C's IDF, as well as their associated languages like Gremlin and SparkQL. Neptune's highly available with read replicas, point-in-time recovery, continuous backup to S3, and replication across availability zones. So we take 6 replicas of your data across availability zones in the regions where your Neptune instance gets deployed. It's secure, and obviously by default most services in AWS are, with support for encryption and at rest and in transit. And Neptune is currently available for preview for our customers. So hop along to the product page and get signed up to use that now. Next on to, from a new service to a service which is one of our fastest growing services in the history of AWS, which is Amazon Aurora. So happy to talk to you about Amazon Aurora Multi-Master, which allows you to create multiple read and write master instances across multiple availability zones, which allows your applications to transparently tolerate failure of any of those master nodes or even the entire availability zone. Single region multi-master is currently available in preview today, and then multi-region multi-master is coming in 2018. So again, if it's a service you'd like to get on the preview for, hop along to the product page and get signed up and have a look around. In addition to Amazon Aurora Multi-Master, we also announced Amazon Aurora Serverless, which is a pay-for-what-you-use model for Amazon Aurora. Take care of all the on-demand deployment and scaling of an Amazon Aurora. There's no instances for you to manage, and you pay only by the second for when the DB is being used. And that is available in preview for you today. So once again, hop along to the product page and sign up if you'd like to get some exposure to Amazon Aurora Serverless. And then on to another one of our popular database services, DynamoDB, which is our managed NoSQL database service. We announced at reInvent this year global tables for DynamoDB. Global tables replicate your Amazon DynamoDB tables automatically across your choice of AWS regions. There's no changes required for your application. Global tables uses all of the existing DynamoDB APIs. supports low latency reads and writes to local available tables, and disaster-proof with multi-region redundancy. And another capability that we announced at reInvent for Amazon DynamoDB is also Amazon DynamoDB backup and restore. So now you can backup tables range from a few megabytes up to hundreds of terabytes of data with zero impact on performance or the availability of your applications. All of those backups are automatically encrypted and cataloged. They're easily discoverable and they're retained until you explicitly decide to delete them. On-demand backup for DynamoDB is being rolled out in our US East 1 regions, our US East 2 regions, US West 2 region, Oregon, and also our island regions as well for you to start using today. And then in early 2018, you'll be able to opt in to use DynamoDB point-in-time recoveries, which will allow you to restore your data for up to a minute anywhere within the past 35 days, which is all very exciting. And with that, I'm going to hand over to Evgeny to talk about storage.
Thanks, Mitch. So every good database needs storage. In fact, what we've seen is that with services like Athena and things like Presto, they've been talking directly to Amazon S3 as their storage backend. So I'm happy to announce Amazon S3 Select, essentially an extension to our API, which allows you to specify using a simple SQL-like expressions, which exact part of large text files that the services like Athena talk to be retrieved. Instead of retrieving entire object from S3, you'll be able to use that API to save on cost and latency and specify exactly the bits that you need to retrieve. So today, just a few formats are supported, things like CSV, and they also need to be compressed in a supported format. And this is available in preview. What we also heard from customers is that they use Glacier for exactly the same use case. So happy to announce that it's generally available in Sydney today. Very similar functionality. Use it with things like Athena and Presto, and don't need to retrieve the entire object from Glacier, so saving cost and latency again. Moving on from storage, security. So I argued with the guys for a while to have this as a first part of our presentation because security is absolutely #1 priority. So I'm happy to talk about Amazon Guard Duty, which is generally available in all commercial regions, including Sydney. In fact, a fun fact that this service was announced with CloudFormation support from day one. I know a lot of our customers desire to have CloudFormation support on day one, so this one has it. The way that the Guard Duty works, essentially you enable it on your central account and also all your other accounts in AWS organization. And the way it works, it will go in and basically look at your things like CloudTrail events. It will look at VPC flow logs, DNS query logs, and so on. And it will give you an actionable intelligence on the threats detected throughout your AWS environment and also through the networking flow logs. So what you can do with this actionable events, you can use console to take a look and find things, perhaps some of your EC2 instances talking to a known Bitcoin mining IP addresses. You can also hook up your AWS Lambda and trigger automated events. So a very, very cool service. In fact, I recommend to enable it on your accounts today if you haven't done already so, and have it as a default service, just like CloudTrail as part of your implementation. Moving on to development and other launches, and back to Ed.
Thank you very much, Evgeny. Let's talk about development now. Let's start with Amazon MQ. It's available in Sydney. It's great. MQ is a managed message broker service for Apache ActiveMQ that makes it easy to set up and operate message brokers in the cloud. Amazon MQ works with your existing applications and services without the need to manage, operate, or maintain your own messaging system. So basically, it takes care of the undifferentiated heavy lifting of managing your ActiveMQ clusters, for instance. Moving on to Cloud9. Cloud9 is a cloud-based IDE that lets you write, run, and debug your code with just a browser. And it's great. Last week, for instance, I was in Seattle in an internal hackathon, and it was just great to use Cloud9 as a collaboration for that. You can basically have local Lambda functions running in the Cloud9 environment and also collaborate with other people. So have multiple developers working on different source files. Now moving to Amazon Kinesis video streams. So Kinesis video streams now make it easy to securely stream video, audio, and other time-encoded data from sources like cameras, radars, thermal sensors, and other connected devices to AWS for machine learning, analytics, and more. And now Alexa for Business. So Alexa for Business is an AWS service that makes it easy for you to empower your organization with Alexa by giving your employees their own intelligent assistant for work. So Alexa for Business gives you the tools to manage Alexa for organization at scale. Alexa for Business also supports a large and growing list of new skills and integrations from companies like Salesforce, Concur, and Polycom that extend Alexa for Business functionality into popular applications and devices customers already use in the workplace. Now moving back to Jared.
Thanks. It'd be great if we could actually get Alexa for Business with a skill to automatically say, Alexa, troubleshoot our audio issue. But at this point, I'd like to thank you all for listening to our coverage of the new services and key new features announced at re:Invent. We've covered an awful lot, but now it's our turn to listen to you. Within the webinar, we're in the process of launching a poll that contains 3 questions, asking if the quality and depth of the content was good, whether our presentation delivery was also good, and whether we as speakers had relevant technical knowledge of the topics covered. This feedback is useful for us to determine what works well and what doesn't work well for you, the audience. While we always strive to make the content relevant and to deliver it in an easily consumed manner, getting feedback on today's webinar will help us continually improve what we present. I'd also like to use this opportunity to talk about one last thing that was announced at re:Invent. We launched free digital training to enable customers to learn about AWS and to build cloud skills. This new offering provides unlimited access to foundational training on AWS services and solutions, plus advanced training around machine learning and storage. It also includes access to a new AWS Cloud Practitioner Essentials curriculum, which helps you prepare for the AWS Certified Cloud Practitioner, a new entry-level certification. Customers can enroll for free digital training through their AWS.training account and choose from more than 100 new digital courses totaling more than 40 hours of training content. We'll also be sending a follow-up email after this webinar with links to a recording of this webinar and to the slides. Feel free to continue submitting questions in chat, and we'll stick around and aim to get them all answered for you. Alternatively, feel free to reach out to your AWS account team for more information. Thank you all for attending this webinar, and go build.